All right, hello everybody. This is the Lab 4 video. So you will need StatCrunch for this lab, not for any calculations, but to make a graph, you will need StatCrunch. So make sure you have your lab manual and access to Blackboard and StatCrunch. Okay, Lab 4, we are looking at the binomial distribution. So remember, the binomial distribution is a special discrete probability distribution. So we take on countable values. Typically, they are integers, and it's a separate set, right? So we can't have every single number between 0 and 1. It's like number of. With the binomial distribution, we're looking at number of successes. So we have the outcomes, and then we assign probabilities to each outcome. Okay. With the binomial distribution, we need to have some requirements met. X needs to be discrete, so that is just the random variable, X. Does X count the number of successes? We need to count successes. X needs to take on binary outcomes. Be careful here. Let's say X is the number of threes seen in 10 die rolls. Well, you can have another number but 3. However, yes, a success would be a 3 and a failure would be anything but a 3. So here X is binary. It's yes a 3 or no, not a 3. Even though you could have 1, 2, 3, 4, 5, 6. X is not the specific number seen on a roll. It's the number of threes. So yes, X is met, or no, X is not met. Okay. Are the trials of X independent? Need to make sure that that holds. Is there a fixed number of trials? So X cannot be the number of times that it takes to see 5 heads, right? Because that could just keep going on and on forever. So there has to be a fixed number of trials. And then also, is the success probability constant between trials? So we know that the probability of rolling a 3 is constant between each trial. So that's not going to fluctuate. If you answer yes to all these questions, X is binomial, and you can use the binomial distribution. So an example, a researcher visits a certain hospital. In one day, 30 babies are born at this hospital. X is the number of babies born on this day that is female. Okay, is X counting successes? Yes. A success would be a baby is female, and a failure would be the baby is male. Are outcomes binary? Yes, female or not female, right? Female is a success, not female is a failure. So it's either yes or no. So the first two are met. Are trials independent? We are going to assume, typically with things like this, we would assume that all the babies are independent of each other, so the gender or the sex of each baby would be independent. Is there a fixed number of trials? Yes. N is 30, looking at 30 babies. Is the success probability constant between trials? Typically with genetics, if we're just looking at an overview and not specifically at someone, yes, 50% probability of female, 50% male. So yes, X would be binomial here. Also think about the prompts in the lab manual. There are 2 prompts here. One is binomial and one is not. So think about those. Those would be good exam questions, so think about those. Okay, so you're a statistician, you work on a game show. We're going to use the class as the subjects. We want an 80% success rate. So the producers want an 80% success rate. We're going to see if there's evidence for this. We have this new game. This is the first game, and we want 80% of contestants to pass this game and go on to the next game. So you are actually going to be doing this game. Okay, so you'll get the necessary materials. You'll get beads. You'll get a wooden skewer. You need 22 beads of one color and then one that is a unique color. You're going to set up your wooden skewer like this. So the pointy end on top, you'll put the one unique color on the bottom and then 22 of one color on top. you will put your results, your individual results in table 4.1. You can get 3 attempts. So if you fail the first time, you can do another attempt. Whenever you succeed, you don't have to keep going unless you just want to keep going. But it's basically yes or no. Yes, did you succeed on any trial, or no, you did not succeed. We're seeing if there's evidence that 80% can succeed. And then your lab instructor will show you the methods. You'll hold the wooden skewer one at a time. You'll take the bead from the top and put it on the bottom. Then you'll do the next one, put it on the bottom, take the next one, put it on the bottom. You'll do this until the unique color is at the top. And then your lab instructor will be keeping time as well. So in table 4.1, in the outcome box, you'll either put success or failure. In table 4.2, this is when we will look at the class data. So we'll get all of the class data and see how many completed it, were successful, and how many were not successful. You will need to create a binomial histogram and StatCrunch. For the success probability, you'll put 0.8. In the sample size, that will be the class size, how many students are in lab that day. Your lab instructor will give you that number. You're going to need this for the discussion questions. Okay. Now, based on table 4.2, the number of successes, the number of trials that you have, is it likely that P is really 0.8? Right? Is it likely that P is really 0.8? So you're going to start with X is binomial, P, the success probability is 0.8, and then in, let's say there are 24, say there are 24 students in class that day. However many successes you see in table 4.2, let's say you have 20 successes. You'll then calculate the probability that X is 20. So you'll say, is it likely that P really is 0.8? You'll get that probability. Okay. You can work, of course, in a group with your partner. Your lab instructor can help you as well. And then you'll answer the discussion questions. So you'll think about theoretically what X represents, like the mean and the standard deviation. You'll look at the histogram and see where your class value falls. So is it a likely outcome or is it an unlikely outcome? And then you'll calculate this probability as well. That's number 6. Question 6 for the discussion questions. You need to do this by hand because on an exam, you'll have to do this by hand and you'll have to show your work. So this is good practice. Okay, and then for the reality check, this one's a little bit maybe trickier than some of the other reality check questions. Think about what N and X should be. So I'll let you read this on your own. And you might have to do some conversions into a fraction to verify the result. And your lab instructor can help you with this if you need. This one's a little bit trickier. Once you get to the reality check, this one takes a little bit more thinking than some of the other reality check questions. Alrighty, that's the end of this video.